Morning again, Year 4. Welcome to our maths video for today. We're going to be focusing on our 11 and 12 times tables. So before anything, can you quickly head over, or you could do it after the video, it's up to you, whatever's easiest. Can you complete 5 studio games and send me 1 rock slam? Please go, go, go. And a quick starter for you there. You've got a range of different multiplication questions, filling in the missing number track and see if you can spot the pattern on question 3. Pause the slide now because I'm going to head over to the answers. Okay, hopefully your brains are now active and ready to go on this Monday morning. So let me actually do it like this. So there are 11 players in a football team. How many players are there in 4 teams? Let's break that down a little bit. We could use repeated addition. 11 players, 4 teams. 11 plus 11 plus 11 plus 11. What we could do is, visually for you there, we could add our 10s. So 4 10s and our 1s, 4 1s, 44. What we could also do, we could either do 11 lots of 4 or 4 lots of 11. And we discussed that in autumn term, how that will still give us the same product. So how about if there are 5 teams? How would you lay that out? See if you can pause it and show me repeated addition and the 2 other multiplication equations that you could do. If you can add in any visuals there quickly, that would be great too. Don't spend too long on this activity. Okay, a little bit of a different way to do it this time. What we could do is we could do our 5 10s, which gives us 50, and then we could do our 5 1s, which gives us 5. So 5 times 11 is 55, or 11 lots of 5, 55. How about our array model here? What multiplication is represented here? Okay, hopefully you've managed to see that there are 11 across and 7 down. It almost allows us to calculate the area in a way as well. But simply, if we count how many are going up and how many are going across, because that rectangle there is complete, I know that the calculation I can do is 7 times 11 or 11 times 7. Okay, what I could also do, 7 times 10. I'm confident with that. That's 70. And then I just need to add on 1 more column of my 7 1s. So 70 plus 7 gives us our 77. What would that look like for 8 times 11? If you're not too confident, draw out your arrays. If you are a bit more confident, see if you can draw it out so that it looks similar to this method here. 8 times 11. Think about multiplying 8 by a nice number like 10 and then adding on another 8. I will show you how that looks now. Hopefully you had something that resembles that in some form. What if we then changed it though to 8 multiplied by 12? Would we need to draw out a whole model again? Or could we simply extend our 1s? So now we have 2 lots of 8. So we have 10 lots of 8, 80, and we have our leftover 2 lots of 8, which is 16. Okay, so you could do 80 plus 16, or if you're confident enough, you can obviously do that method straight away. See if you can start applying this now into these questions. What I'm going to do is I'm going to set the question. I let you freeze the video, and then I'll go over the answer afterwards. So a box holds a dozen eggs. If you're not too sure how many a dozen is, that is 12. So think carefully about how many are in half a dozen or in a baker's dozen. See if you can figure out what a baker's dozen is. How many boxes are needed for 24 eggs? So one box holds a dozen eggs, 12. How many boxes would be needed for 24 eggs? I'm going to put a few prompts on there just to guide you. Feel free just to answer the question if you're feeling confident enough. What I've done there is I've put 1 dozen in one box, and then I've put another dozen in another box, which gives me 2 dozen. The calculation for that is on the screen. 24 divided by 12, which equals 2. So there are 24 eggs that are put into a dozen boxes. This time, we know how many boxes there are. How could we use our eggs, our red arrays there, to figure this calculation out? If you're feeling confident, pause the screen and you do it for yourself. If not, let's watch as it's explained here. So if we distribute them evenly, so far I've got 1 egg in each box. And again, I have an equal number of amounts, so there are 2 eggs in all of my 12 boxes. And this time, 24 divided by 12 equals 2. So the previous way was 24 divided by 2 equals 12. Now, 24 divided by 12 boxes gives us 2 eggs in each box. And that's how we group or how we share. Okay? So, can you answer these 3 questions here by using one of those visual pictorial methods? You may want to use the array method. You may want to show me 4 times 10 and then 4 times 1 and add them together. It's entirely up to you. For here, 12 multiplied by 11, you might want to do 11 times 10 and then extend it with another 2 lots of 11. It's your choice, but freeze the screen now and I'm going to put the answers. Obviously, I can't see your visual representations yet, but I'm going to put the answers to those multiplication questions on the next slide. Or no, I'm not. That's funny, isn't it? So you just have to send it to me, but 4 times 11 is 44, 3 times 11 is 33, and 12 times 11 is 132. So question 2 says, Ron uses a bar model to represent 84 divided by 12. Can you see what Ron has done incorrectly? And can you explain what he has done? And then the second part of that question, can you draw the correct bar model? So I've got 84, I've got my whole here, whole amount there. And I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have divided it by 12. However, I'll let you have a think about that, see if you can explain it. Question 3. Amir is making pictures using shapes. Here is one picture. Okay. He makes 12 pictures like this one. So how many shapes does he use altogether? First of all, and then secondly, if the pictures are all exactly the same, how many of each different shape does Amir use? So how many squares would he use if he draws 12 pictures? How many stars? How many triangles? How many circles? Question 4. Mr. Scott is organising a cricket tournament. There are 11 players in a cricket team. 5 teams have signed up for the tournament. So how many players have signed up? This is similar to our example earlier on. Then Mr. Scott needs 132 players signed up to go ahead with the tournament. So this is the inverse now. You're going to need to think about division. Remember that we're focusing on 11 and 12 times tables. And then finally, your challenge X. Dexter's been looking at the 12 times table. He notices something when he adds the digits of the multiples of 12 together. So the digits, so 12, 1 plus 2, 24, second multiple of 12, 2 plus 4, 36, 48. So that's what he's doing there. 12, 24, 36, 48. He's adding those up. And then he's got 3, 6, 9, 12. Dexter thinks the next number in the pattern will be 15. Is he correct? Explain your answer. And finally, what happens when he tries this for all of the multiples of 12 up to 12 times 12? Is there still a pattern? So I will respond to your answers via email for this lesson. I made a mistake initially because it is a lot of visual representations. Enjoy it, and I look forward to seeing your rock slams that you've sent to me on TT Rockstars. Bye-bye.